Back. This is Stat5 1. What is probability? Problem 1. For each problem, select the best response. A phenomenon is observed many times under identical conditions. The proportion of times a particular event occurs is recorded. This proportion represents the probability of the event, the proportion. Okay. The collection of all possible outcomes of a random phenomenon is called the sample space. Okay. Next. Probability is a measure of how likely an event is to occur. Match one of the probabilities that follow with each statement of likelihood given. Type the correct letter ABCD in each box. You must get all the answers correct to receive full credit. This event is impossible. It will never happen. Impossible events, probability is 0, so the letter that goes here is C. This event will occur more often than not. Okay? More often than not. So it is, I would say, D, because it is the D or A, basically, D or A. So I will hold off on it until I get the other numbers. More often means probability has to be higher. Okay? Higher than not. So it can be both this and or this. So let's look at the third one. This event is very unlikely to happen, but it will occur once in a while in a long sequence of trial. So you see that is very low probability, but it's not zero probability. So it will occur once in a while, but likelihood is very low. So that 3 is a B. This event is very likely to occur. So high chances of occurring, that is D. In other words, this has to be A. This event will occur more often than not. So A is 0.55, which is 55% likelihood. So this event will occur more often than not. So A. Next problem. A basketball player makes 90 out of 140 free throws. So frequency 90 out of 140. We would estimate the probability that the player makes the next free throw to be 90 out of 140. That's the probability that the player will make the next free throw. Because 90 out of 140, he was able to make the free throw, right? All right. Next. In drawing a single card from a regular deck of 52 cards, a black or a face card. Let's open a card, right? Standard deck of cards. Let's see some pictures of standard deck of cards. Same, well, they are all good. Oh, it's gone to YouTube. So I don't want a YouTube video. That's also a YouTube. Let's go. Let's look at this picture. Okay. So that's spade, hearts, clover or club. Those are diamonds. I hope the picture is clear. Let's get another set of pictures. That's better. Is that, that's even better. Okay. So there you go. That's club, spade, hearts, diamonds. You have ace through king. This is a standard deck of cards. All right. So what are we doing? There are 13 in each suit. 13 plus 13 is 26, plus 13 is 39, plus 13 is 52. 52 cards in all. So what is the probability that, so you're drawing a single card from 52 cards. What is the probability of getting a black or a face card? Black are these cards. So 26 cards. Face cards are these cards. All right. So you have black cards 26, and then 1, 2, 3, 4, 5, 6. 26 plus 6 is 32. So it will be 32 over 52. Now here I do have to worry a little bit. Sometimes people call aces to be face, but let's see what, I wouldn't call them ace. Submit and check for yourself. It is incorrect. So let's add the two more aces. So let's say 34. That's correct. Okay. So why did I get two more aces? These are the two more aces. So these are the black cards and then more face cards. Look, there were already face cards, but they have been already counted in the black cards. 1, 2, 3, 4, 5, 6, 7, 8. You want to add 8 more cards to the 26 black cards to get black or face card. Okay, so 34 out of 52. Probability of getting a black or a 3. So black, there are 26 in all. So threes, these threes have already been counted. So let's count these two. So 26 black cards and 2 more 3 cards. So 28 out of 52. A black and a queen card. So you want a card that is black as well as a queen. So only 2. These two are both black and queen. So 2 out of 52. Black and a face card. So you want a black card which is also face. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. 8 out of 52. A face card or a number card. Number cards. So number cards are all of these. Okay. Face card or a number card. So these are all number cards. The rest are all face cards. So basically you're looking at all the cards. So 52 out of 52. All right, let's check. They're all correct. Okay, so next problem. Let's see. Probability of C, A, B, C. Probability of A is 0.81. Probability of B is 0.17. So what is probability of C's? Look, probability of everything has to be 1. Combined has to be 1 because that's the entire sample space. Probability of the entire sample space is 1. So I don't have C, but I have A. So from 1, I remove probability of A and I remove probability of B. So take away this, that gets you C. So from 100%, which is 1, take away probability of A, take away probability of B. All right. What is probability of A complement? A complement means everything other than A. Well, that's 100% minus probability of A, 0.81. Okay. Next problem. Here is a probability model for the blood type of a randomly chosen person in United States. Okay, these are all the probabilities. Blood type O, A, B, AB. O has this probability, B has this probability, A has this probability, B has this probability. AB, we don't know. Well, we do know probability of everything is 1. So this is 1 minus this, minus this, minus this. That's how you would calculate this. All right. So let's go over the questions. So Maria has type B blood. She can safely receive blood transfusions from people with O and B. What is the probability that a randomly chosen American can donate to Maria? So Maria can obtain blood from O, people with O blood type or B blood type. So you want to add these two probabilities. 0.28 plus 0.07. So think about it, right? You can add it using calculator, or notice 28%, 7%, 35%. The probability that a randomly chosen American has type AB must be, well, AB must be from 1, take away, let me open a calculator for us. Okay. So for AB, from 1, take away blood type O probability, then take away blood type 5, A probability, and take away blood type B probability. I get 1.5. Okay, 0.15. That's this guy. What is the probability that a randomly chosen American does not have blood type O? Not have blood type O is everything except this. So I want to take away from everything that's 100%, I want to take away blood type O probability. So that is 7.2. So there you go. Okay. That completes Stat 5.1. Okay. So next video we'll continue on 5.2.